We are now going to use our properties of logarithms to either expand an expression as much as possible or condense. So you'll notice in my first example, they're asking me to expand it as much as possible. When I look at this particular logarithm, I see all three properties are present. I see a quotient where two terms are divided. I see a product where terms are being multiplied. And finally, I see powers. So when you see all three, you have to first ask yourself, what are all terms part of? And they are all part of the fact that we have a quotient. So when we have the log of a quotient, we start out by taking the log of whatever term is on top. So in this case, I'll take the log of 12x to the 8th, and I subtract the log of whatever term is on bottom. So the log of y to the 9th. So again, remember you are always associating the division symbol with subtraction. Now, my next step, I'm going to deal with the product that I have. So since 12 is being multiplied by the x to the 8th, when I come in here, I'm going to break those apart with addition. So 12 is one factor. I'll take the log of 12, and then I say plus the log of x to the 8th, since x to the 8th is the other factor. So again, when you are dealing with the log of a product, remember you're always going to add those terms together. Now, don't forget we still have the minus log of y to the 9th. So the last thing that I will deal with is the fact that I have some terms that are being raised to powers. I have an x to the 8th here, and I have a y to the 9th. And our properties tell us that we can pull those powers to the front and multiply. So log of 12 is just going to stay log of 12. But on this next term, when I pull the 8 to the front, I've got plus the 8 times the log of x. And then I have a minus sign. When I pull this next power to the front, I'm going to have a 9 times log of y. So the powers in each case simply get pulled, multiplied by the logs of whatever that original term was. So this would be my final answer for the expanded form. Now, with this second example, notice that they are asking me to condense the expression as much as possible. So when I'm condensing, I have to go in here and look at whether the logarithms were added or subtracted. And in this particular case, they are being subtracted. So when I go to condense them, which means putting them back together as a single log, I have to remember that subtraction was associated with a fraction. So notice they're spelling log as ln this time. The z will go on top since that term came first, and the 4y will end up on bottom. And at that particular point, I have condensed as much as possible. With my third example, again, they are asking me to condense as much as possible. And so I'm going to work left to right. Anytime I have addition and subtraction, I will work left to right. But I'm also going to notice that if I have powers, like I do in this case, I've got a 5 in front there, and I have a 5 in front there, I'll actually work to put those back first. So if they were powers, or if there are numbers in front, they came from powers. So I'll put those back first. So I have my natural log of 15 plus, instead of 5 times the natural log of x, that will come the natural log of x to the 5th. And I really don't need to put the parentheses. It's okay without it. Leave the minus here. Don't take it with the 5. And then the 5 becomes the power of y. So you get a minus ln of y to the 5th. Now, going from left to right, I notice that I see a plus sign first. So with a plus sign, I put those terms back together as a product. So I have the natural log, and I'll multiply the 15 times the x to the fifth because of the fact they were added up here. I still have the minus natural log of y to the fifth. And then on my last step, I notice that those two logarithms are being subtracted. And I know when they are being subtracted, then to put them back together as a single log, I have to make a quotient. So I have a natural log. The 15x to the fifth goes on top since it came first. Y to the fifth goes on bottom since it came second. And so my final answer would be there. This last example, I'm going to have to use my change of base formula. And so, or if I have a calculator that does it, you can punch it in exactly like that. With my change of base formula, if I don't have that, in my calculator, I'll first take a regular base 10 of log, or base 10 log of 86, and I'll divide it by the base 10 log of 18. So let me show you what that actually looks like. And they're asking me for 2 decimal places. So in this particular case, with 2 decimal places, that 1 will tell me to leave the 4. So I would say that, well, not necessarily my x, just that particular expression is equal to 1.54 with 2 particular decimal places.